Good morning. I welcome you all to the day 7 of the webinar. That is the last day for today. In today's session, we'll see how can we collect data from the census and why do we need to collect data for the census. In addition to that, what is the requirement and what is the use of having the data and why is it important in IoT. And once we get a data, how can we go ahead, do a model of the data, analyze the data, and even do have a visualization of the data. Until now, we used other third-party applications or servers, that is ThinkSpeak and so on, to have our data being logged into their servers. And when the data is being stored there, and we used to have the analytics or visualization on their servers. And today we'll see how can we collect data directly and store them in a CSV file, that is comma separated values, or any other formats. And then how can I read those files again, and then either we use Excel sheet to analyze the data and have a graph for the same, or how can I use Python and apply the data science libraries or machine learning libraries and have the graph and understand what is there inside the data or get the insight of the data what we have collected. So without a further delay, I'll just quickly go ahead and show the agenda for today. So first is we'll collect the data from a Node MCU or Arduino. You can use any of the both. Remember that I'm using the DHT11, that is temperature sensor, to collect the data. I'll be logging the temperature and humidity, and next we'll see why we need to collect the data. We'll see analysis and plotting of graph in Excel once we have collected the data. We'll see the NumPy libraries and Pandas libraries, and then graph the same using the data science techniques. So first, we'll upload the program to the Node MCU, and then see the readings what we get from the temperature sensor. So I'll connect my Node MCU first. So here's my normal program what we had for the DHT11. So you have various types of sensors, that is DHT21, 22, sorry 21, 22 and 11 also. So mine is 11. So I have uncommented 11 and then remaining 2 I have commented. What I'm doing is very simple at the last, that is I'm printing the humidity and a temperature and the temperature in Celsius and Fahrenheit. So with this it's just going to print every single thing in one line by line. So we'll see how the data is being printed. I have uploaded the program, or I will upload it once again. It's in content properly. Click on upload. It will not save the file. This is a basic normal program what we had for the what we get for the DHT11. So it's uploading now. We'll wait until it has been uploaded, and it should not take much time of ours. So it's done uploading. What I'll do is I'll see the serial monitor and check out whether I'm getting the data on a serial monitor or not. So let me open the serial monitor first. I click on a serial monitor, and here you go, like you can see the values, that is 76 is my humidity as mentioned here. I have added this comma, you can see on the programs, that is serial print, and I'm printing a comma. So I'm getting a print value here at the first of the line, because I'm going to add a timestamp by using another software where I want to, from which I'll be logging the data. And then humidity I'm printing, that is 76, and then the temperature in Celsius, that is 27, and then Fahrenheit in unit, that is 80. So with this I'm getting my data properly here, but I'm not getting a timestamp. I'll be adding that timestamp using another software. So now once you're getting the data into your serial monitor, now the question is I need to log this into a file. So for that we have many, like you can store the data into a CSV format or a Excel format, but the most preferred way to analyze is the data is having it in a CSV format, that is comma separated values. So how can we store this values in a comma separated values now? This is the question. So for that we have many other ways, like you can even have an Arduino sheet which will have a memory card, and in that you can store the data and then later copy the data to the PC or a machine and then analyze it. And you also have many other tools also, but the very famous tool, or like the much popularly wise and easy to use tool is Terraterm. So I'll take you through the Terraterm and show you how can you download it. Just search for Terraterm, and this will take you to this page, any page like Terraterm open software. Okay, and then you have here latest version available on download page. So from here you can click on download and download your Terraterm. Once you download your Terraterm, I already have installed it. Just follow the installation process, and then so here is my Terraterm. So I open with the Terraterm. So this is how your window looks like in a Terraterm. So it asks you for TCP or IP address if you are connecting it through the IP, but I'm not connecting it through the IP address. I'm connecting it through the serial. So I'll click on the serial and then it select the port serial. So mine is COM10, right? So I'll click on OK. It says cannot open COM10 because as I had said earlier, it can only communicate one way. I mean, like it doesn't support like it cannot give the data to two ways. So my serial monitor is already open. I'll just close the serial monitor here, and now I can access it. So again, go to the file, click on a new connection, and then select OK. So now you can see here, I'll just zoom it up. Now you can very clearly see here I'm getting the values 77, 27 and 81. That is humidity, temperature in Celsius and temperature in Fahrenheit respectively. So this is how I can, now I'm getting the same value what was getting printed in the serial monitor there. I'm getting the same thing in a Terraterm now. Once I am getting the value, it's an indication that my connections are correct, and I'm ready to log the values. So for that, what I'll do is click on a file and then click on a log. Then it asks you for file name. So I'll just give it the file name as temperature, and remember not to forget to add .csv, because this is the format in which I'm going to save. So remember you need to enter the format, that is CSV, after the file name followed by .csv for the thing. And now, as I had said earlier, I don't have a timestamp in this reading, so I need a timestamp. So I'm going to add a timestamp by checking it here. I check timestamp and then I'm done. Now I'm clicking OK. So now we'll just wait for a few minutes, not just 1 or 2 minutes, until the values are being logged, whatever the values I'm getting. So let me increase the temperature by keeping it near to my CPU fan. At least I should get some value being increased. So let me check out. Yes, it's increasing slowly. 27.50, 27.70, 90, 28, 30. So the same values will get logged into a CSV file. So let me just increase the value to the maximum I can do it. I think so my CPU is running very hard to live stream and record. So we have enough data now. We'll just keep the temperature sensor aside now. I'll not log any value, any more values. Let it decrease. So we can see it's falling down to 38 again. When I had kept it just near to the CPU fan, it was increasing to 40, and now it's decreasing again. So let me make it decrease to the 36, something like that, so that we have a proper graph and I can show you in a better manner. Okay, we are reached 36. We have reached 36. Now we'll go to file and then click on a show log dialog and then click on a close. Now once I've clicked on a close, now you can see, like, if I go to the file again, it asks me for a log. That means the file is being saved. So the file is being saved here. So my file is here. Let me just minimize. You can see the file here, temperature. I'll just open this temperature file. Perfect. Now here you can see my complete values being logged with the timestamp, and this is, I'll just edit this timestamp, humidity, temperature in Celsius, and temperature in Fahrenheit. So now you can see here I have logged the complete values here. So my values are, I'm having how many? 150 readings. So now I have this much of data with me. Now what I can do is, like, if I just give you the data, we need to analyze the data to have the quick look. For an example, as of now I just have 144 values. Consider you have kept the recorded the temperature or recorded the data for one complete day, so you'll have more than 10,000 of data with you, and that depends on the delay of the delay you give between the two data to be collected. So here I think so it was just 1 second or 2 seconds here, and if you just give 1 minute between the two delays, might be you'll have a less data, but still we'll have data in thousands, in numbers of thousand. Now as I have this much of data, and if I give you the data, it's completely useless until you find something out of it, until you get an insight out of that. That's the reason we need to have data. Data is driving every industry, every business, and everything. And even IoT, without analyzing the data or have finding the data insight from the data given, it is useless. Just having the data is of no cost. And now the data is being generated heavily from various resources. So we need to have analysis of data and then get an insight from it. So as we have a little bit of data with us now, let us analyze it. How? So I'll just select these four columns completely till 144, 150 values. Okay. Now go to the insert and then click on a charts, and then I'll select one chart. Okay, I'll select, okay, let me select with this. So now this is the, now this is the graph I got from the data I collected. So now you can easily say, just by a glance, You can also change the type of graph you want to many other various designs here you have. Now you can easily say that my first series that is in blue color, that is humidity, and the second series is in orange color, that is my temperature, and the third series is in Fahrenheit, that is both temperature and Fahrenheit. Now you can easily say just by looking at a glance that at this moment of time, that is, you can see, I'll just zoom it up so that you can see the timestamp. You can see at this time, that is 11:43 and 2 seconds and 218 milliseconds, the temperature was to the max, and it was lowest on the time 11:41:54, and the humidity was to the peak low at 11:43 and 2 seconds, and it was to the maximum at this time, that is 11:41. So this is how, just by collecting the data and having them plotted or having the visualization, you can easily get to know, or you can easily get an insight what is there inside this data completely. Now without any, like, it didn't even take us a minute to analyze this complete data and then show that in a graph so that we can understand it easily in just a matter of seconds. So this is how, why we need it. So in this example I just showed you with having the DHT11, you can always use for, consider I have one more data set which I have collected, where I'll be showing you using the data science techniques, where there is a like temperature from both inside the home and outside the home, and it was been recorded for a very long time, so I have more than 60,000 logs there. So you can use it for various applications. Now consider like you are just counting the persons entering and exiting, and you have just, so you just keep on collecting the data for 10 days. So you can easily say, after having the complete data collected, you can easily say at what day of the time, or what, in which day there was a maximum number of in and outs. Or consider like you use the same thing in automobile industry or automobile, and then you record the vibration level. You can log the complete values for complete of your journey, and then once you get the data completely and then analyze the data, you can easily tell like at what moment of time or at what speed. You can do is like have two parameters, speed and the time, and you can also have three parameters, speed, time, number of persons in the vehicle, and based on this parameters you can see like at what moment of time and what was the speed and at how many peoples were there, and on which moment of time there was a highest vibration level, and at what moment of time the vehicle was running at the most smooth manner. And based on that value and based on that insights what you get from the data being collected, you can use that to have the battery efficiency for the next time, or to set up or tweak the parameters of the vehicle, or the load arrangement or the speed arrangement on the various road conditions, so that you get a proper efficient drive. So this is how it can help you to get the insights and get your things easily done. I'll also show one more example. Let this chart be here in the down itself. Now consider like you don't want to have this two things. You just want to have is just humidity and the time. So what you can do is just select this and this completely. Okay, we'll have two things and these two columns. You can again do the same way. That is just select the data which you want to put in the chart, and then go to the insert and then select the chart type, and that is scatter, and then you have various things. Then you can choose scatter, you can choose scatter with smooth lines, you can choose scatter with uh, straight lines, and so on. You can also go with this thing, that is lines, 2D lines. So let me go with the 2D lines this time. Okay, I'll just take the smoothest one. I think so. This is the okay. This is much better. So now I have this, that is in this chart I have three things. The very first thing in this is I have all the three, that is humidity, humidity, temperature in Celsius and temperature in Fahrenheit, and in this I have temperature and humidity, that is temperature in Celsius and temperature in humidity, and this is the timestamp also here. So I can click anywhere at the point of the date, anywhere in the plot, and then check out the time at what time it was. You can get that function here, that is temperature and so on time, and that, and which value it was the highest, everything. So this is how you can collect the data and then store the data, that is log the data, and then analyze it using the Excel. Now we'll switch back to Python and then see how can we analyze the data there. So let me go to my and switch the window. So to do this now, what I want to do is I need to have Python libraries. I need to get installed with the Python. I need to have few knowledge about the Python and so on. And I'll assume that you know a bit of Python, and if you don't know, it's pretty fine that you can easily learn it. It's very simple to learn and not a much of difficulty to learn. And the next thing is getting the things installed, that is installing the libraries, installing the Python IDE and all the dependencies and so on. We'll not do any of all these things. It's pretty simple now. We are just going to use the online platform to do every single thing of what we can do with Python IDE or so on. So we'll not use the machine power, that is laptop power, or the computer processing power. Instead we'll just going to use it so that it's easier to get access. So with this, I'll not show you any of the installation demo and so on. I'll just take you to the platform, that is you can search for Google Collab. It is also called as Collaboratory, and it is called Google Collab. So once you click on Google Collab, make sure that you need to have a Gmail account to sign in, and everyone have it. So use your Google account to sign in, and once you sign in, you get this window. Let me create a new notebook, and every project what you create on Google Colab, or even in any data science project or machine learning project, it is called IPYNB, or a notebook. That is, we use the Jupyter notebook and so on. So even this is called a notebook, and this IPYNB here stands for Interpreted Python Notebook. Let me rename it to webinar day 7. Now when I have taken you to this Google Colab, let me just introduce you what is Google Colab and how it is. So it is a Google product which lets you do and analyze the machine learning and data science projects and so on. It provides you with all the required tools for free. This is just a normal, you can have a new notebook, upload the notebook from the Google Drive. You can even copy a notebook, save it as a IPUNB in the that is offline version also, and so on. You can have different runtimes, that is just a normal runtime, graphical runtime, and so on. And here it is, if you go to the other side, this side, you have something like connect. So once I start executing something, it'll get connected, and this is your account. Let me execute something and then show you what is the processing power they provide you for this. Consider, like, just use a normal print and write hello, and then press enter. So now you can see when it is executing, you can see the status. So this is where you can see the status of what's happening. Now it was connecting, now it is into initialization, now it is saying connected, and the moment it is connected, this got executed, this line of instruction got executed. and I got the output here. Now the thing I wanted to show is how much is the disk space and the RAM they provide you. So if you just go near to it, it says you connected to Python 3 Google Computer Engine backend, and the RAM they are providing is 12.72 GB. That is a huge amount of RAM. And the disk space what they are providing you is 107.77 GB. So this is how much RAM and the space they provide you for doing your own work on this servers. So it really doesn't matter like what type of laptop or what type of computer you have, whether you have a 4 GB RAM or a 20 GB RAM. If you have this, if just the browser works perfectly, you can execute anything. You can execute even the biggest file of data, because it will be done everything on the server, on their server, and they have given you so much of space and so on. And this is for free. This is completely for free. You need not pay anything for this. So with this said, we'll jump directly into the analysis part, what we want to do. Before that, we need to have some libraries. In this, I'll not be showing much in detail. I'll just show you the overview, how can you do the analysis and so on. So we need few libraries for that. That is to execute and do, like there are different types of libraries. For data manipulation, you have something like NumPy, Pandas, and so on. For having the visualization of the data, you have Seaborn, Matplotlib, and so on. So we'll be using few of those libraries itself here again. So before that, so I want to import those libraries. So what I do is click on write import. Now I need pandas as PD. What I'm doing is like I cannot call a pandas everywhere, so I'm giving it as a PD and then import numpy as np. Remember that you are going to use the same libraries and so on in machine learning also. Machine learning, data science, and all use the same libraries. You have that scikit-learn and so on. And then press Control Shift Enter, then that will just get executed. So it got executed, but I didn't get any confirmation, but it got executed. So let me write print if it is executed, like print executed. If you just are trying to getting started with Python, you can watch my YouTube channel and the playlist that is data science. In that I have basic of the Python to get started with. It's pretty easy to start with, so you can always check that out. Now these two libraries are installed, that is these two libraries are imported into my notebook. Now before I start visualization, I have imported the data manipulation libraries, that is pandas and numpy. Once I've imported these two libraries, now the question is I need the data now, and the data is stored in my computer. If it is online or into some website, you can directly write is give it a file name that is considered like I give a file name file and then equals to pd.read, and if it whatever the format it is, if it is an Excel then you write Excel, and if it is in CSV, right, you write read underscore CSV, open the bracket followed by the link whatever it is, and then it gets you the thing. But as it is in my local machine, that is on my computer, I'll use other function to import that thing here. Just a minute. So I'll import other. So to import the files locally, what I have to do is click right from google.collab, google.collab, import files, import files into, sorry, files enter, upload, then write uploaded equals to files.upload. This will give you a prompt to choose the file from the local machine. So once I press shift plus enter, you can see this, it asks me choose a file. So I'll click on choose a file and then select. So my file is here in the desktop, I think so. Yes. So here's my IoT temperature file. I'll just open it. So I have, we'll see what is there inside this file and so on. Until then, we'll wait until it is been uploaded. That is, it's just 6% done until now. We'll use different types of plot and techniques to see different types of plot in this. We'll also see the description, what is there inside the data, the information what is there, and the size and shape of the data, that is how many rows are there, how many columns are there into it, and so on. And all just by using a single line of instructions. 35% done. So it's 100% done now. So my file is being uploaded. To get that file now, I'll use import IO, press enter, and then give it a name. That is, let me give it a name, file equals to call up the pandas, that is pd dot read, and as it is in the CSV format, underscore CSV, and then call up IO dot bytes IO, open the bracket, uploaded, that is the thing what we have given up earlier, uploaded, and then give the file name, that is, the file name is IoT temp.csv. So I've given a file name and then the brackets are closed. Yes, done. Now shift enter. So now I have imported the file. I have also read the file into a data frame using the pandas pd.read, and the name of the file is file. So now if I write file.head, and this head will print me the few values, that is 5 values from the top of the data frame. So you can see here, this is what is there inside my data, that is IoT temp CSV, where I have 5 fields, that is ID, at what moment of time it has been taken, and room ID, noted date, temperature, and whether it was outside or inside the room. So file head will give the first 5 values, and if you write just the same thing and write file tail, this will give you the last 5 of the data set. So the number of data sets I have is, I think so, 97,605 values I have. Yes, you can see it started from 0, 1, 2, 3, 4, and the last value is 97,605 data sets. So these are so much of data, and that's what the time it took for importing it. So now I have this thing, so I can let me see the information what is there inside this by using I'll call the file dot describe. I'll use this function describe, sorry, and see what is there, like just see a quick look into it. So temperature, so count are this many, that is 97,606, and the mean value is 35 and the standard is 5. Minimum reading was 21, 25% this, and 75, maximum is 51. This is the brief description of the file, that is the data file what I have uploaded here. If we just use this another one, that is, I'll just see what is the how many rows are there and how many columns are there, that is the shape of the data file. So I can use this file dot shape, and this will give me the number of rows and columns into the data set. That is, we have 97,606 columns, rows and 5 columns. So 97,606 and 5 rows and 5 columns. Now you can also see the whether like you have any null values present, that is 00 values present, or is there any missing values and so on by this file dot info function. So if you, now you can see here column ID I have 97606 counts, and there is no null object, no null. In room also I have no null values, in noted date no null values, temperature no null values, out in no null values. So there is no null values, and there is that is temperature is in integer type, and remaining all are in object data type. So it gives you the data type summary, that is 1 as an integer and 4 are objects, and the memory it used was 3.7 plus MB. So here you just got a file info. So once we got a file info, we know there is no null values, we know there is nothing such. Now let me start with visualization. So for that, first what I'll do is I'll start importing the data visualization libraries. So first I'll import MATLAB, sorry, not MATLAB, Matplotlib. You have Matplotlib as PLT. Yes. I'll also import Seaborn. Seaborn as SNS. The name what I'm giving here, the as PLT SNS, you can give any name you want. I'm just giving so that it's easy to understand. And usually everyone gives this. You can always give any name you want, but the matplotlib.pyplot should be the same and Seaborn, because if you change that thing, then you cannot access the library for that. I'll also, I think so, these two are enough for me to have the data visualization for now. So let me go back and print right imported, just to get a confirmation. Yes, it says imported. Now let's start the visualization. We'll see how many values are from the in and how many values are from the out. So for that, call up the figure, comma axis equals to plot function plt dot subplots, and there is only one subplot, so 1, and then give a figure size, that is figure size, let me equals to, let me make it to consider 8 comma 6. So then as after this, now I'll call up SNS, that is seaborn, and then the plot type is, I'm calling as count plot. You have many various types of plot, that is KDE plot, we have a scatter plot, line, bar, and so on. I'm calling count plot for now, and then giving the file name, that is file name is file itself, and which parameter I'm going to use. So my intention was for this project to have in and out values, so I'll just open this and then call up whatever I had wanted. So in slash out, is it the right thing, in or out, or it was out or in? We'll just check out a moment. So yes, it was out in, not in out. So if I just give in out, then it will tell there is no such column found, out slash in. So this is right. Now I'll call the plot function to plot it. Plot dot show. Press shift plus enter. Yes. Now you can see out of all the values I had 96,606 values. This is the number of values what I have, that is approximately something around 21,000 or 22,000, that is in, and the remaining are the values counted from the out. So it just took 3 lines, and then we got how many were in and how many were out of the 96,000 plus values what we have logged into our data set. This is the power of having the visualization tool and the libraries what we use in Python for data science and machine learning. Now what we'll do is we'll differentiate and plot the graph out temperature and inside temperature. So for that I'll just to save the time, I'll just copy the first line. I'll copy this full and then paste it here. Yes, and I forgot to tell you, like every set of instructions what you see in the columns here, that is every set of rectangular boxes, these are called cells. So these are cells, like whatever is there inside a cell, you can run it and that will get executed. If you want to provide some instruction, you can always go here and then click on text, and this text will not be executed. Like for an example, I here write visualization of inside and outside temperature, and then press enter. So that is just a text that will not be executed, but whatever there in the cell, that will be executed. So I'll just paste it here, whatever I have copied from up, but I don't need this now. Let the size of the figure be a bit larger so that I get a clear understanding. So let me make it to consider like 15, and this 2 consider 9. Okay, and there is no subplot, so 1. And this time I'll be using a KDE plot. So I'll just and that KDE plot also comes under okay, sorry, Control C. So this comes under SNS. So SNS dot KDE, that is I'm calling KDE plot. So I will just use a KDE here, KDE here, KDE plot. So now you may ask me what is KD. It is like kernel density estimated, which is used this is used for visualization the probability of density of a continuous variable, and it belongs to the, it is a seaborn library, KD plot, and then open a bracket, write the file name from which file you want to get the data file, and then location, that is indexing it, open a bracket, again a file name, and then which column, that is out in, because there is what I have the temperature for both in and out. So from there I'll just parse it, that is out differently and in differently. So here I'll just call up this and then equals to, if it is in value, if it is equals to out, then, and the temperature for the same, I need a temperature also. So again temp, it's only these two values, and then okay, comma, I'll have it shaded. Okay, let me have a shaded, shade equals to true, and the axis assigning it to ax equals to x, and the label for that is I'm giving label equals to temperature inside. So now I'll just copy this for the same and then change the into out and then paste it once again, control C and control V, and then change this to in, sorry, this is outside. So I'm done. Now I'll just call up the plot show function to show the plot, plot dot show. So now you can see here I got my graph for temperature inside the room and temperature outside the room. So here is my legend, that is orange is temperature inside and blue is temperature outside. So I think the temperature outside was much lower than the temperature inside. So I just click it or have out equals okay. So now if you click on the graph, you can see here that there is a shade between this. If I remove the shade from here, make shade equals to false, if ALSE false, and press again shift enter, I'll not be having that. Why so? Okay, shade equals to false. Hmm. I'll remove this. Okay, so if I remove the shade part, that is by default it is to a false, but I wanted a shade, so I added that shade. So I'll just write control shade again. Shade equals to true. By default it is false, so you'll not get any shade. So this is how you can have a huge amount of data collected into a CSV format and then use this Python libraries, that is that machine learning libraries, data visualization and data manipulating libraries, and then get the insight of the data in just seconds, just writing few lines. You can also always use the Excel also, but Excel sometimes have less functions than this and you have more flexibility using these techniques and using this programming, that is data science and machine learning techniques. These are very powerful libraries. You can always get as much things you want to get the insight from the data. So with this we finished the session for today, and I also want to extend my thanks to all the participants who has participated in this 7 days webinar. It was really a good time to have this 7 days of webinar being shared and the knowledge being shared with you all. I hope you all got a good understanding and a brief insight to the IoT with some advanced topics like this, and the previous we had Firebase, database, and so on. I wish you all the very best for your upcoming future and prospects. If you have any doubts, please let me know in the chat session, or I'll be providing a feedback link. Please let me know your feedbacks and how was the 7-day webinar. With this, I end up the session for today. Thank you all. Thank you for being with me for this 7 days.